So welcome back guys. Next we will discuss the data encapsulation and decapsulation. So in this slide you can see that data encapsulation happens on sending machine. That is the machine which generates data. And data decapsulation happens on the machine which receives the data. That is receiving machine. So in the middle you can see the TCP/IP stack comprising of application, transport, network, data link. So in data encapsulation, the application generates a message. Now here, the application could be any application running on the sending machine. For example, the application could be as simple as your some messenger, or it could be as simple as browsing the internet through web browser. So at the end of the day, any network applications generate a data. This data is passed by the application to the transport layer. Now in this case, the transport layer means that any protocol, transport layer means it could be UDP protocol, it could be TCP protocol, or it could be any other transport layer protocols. What does transport layer do? The transport layer attaches its own header, which is called transport layer header. Now depending on the transport layer protocol, whether it is UDP protocol or TCP protocol, the transport layer attaches the corresponding header, that is UDP header or TCP header. And the vital information that is contained in the transport header is the encoding of the information of sending and receiving process. So note that the transport layer header contains the information of the sending and receiving process. Now, what is that information which identifies the process? We will discuss that in detail when we will be discussing the transport layer, because there has to be some process or some application which is running on the receiving machine. So the transport layer encodes the information of the process which is running on the sending machine and receiving machine. Once the transport layer attaches its transport layer header, the combined message is passed to the next layer in the TCP/IP stack, which is the network layer. Now the network layer protocol could be IP protocol, it could be IPv6 protocol, or it could be any other protocol. But the most famous protocols are IP and IPv6. The network layer attaches its own header called IP header. Or if the network layer protocol is IPv6 protocol, then it will attach IPv6 header. And in this network layer header, what is encoded is the source and destination IP address. That is the identity of the source machine, that is sending machine, and the identity of the destination machine. Now, the identity of the machines are identified using IP addresses. So what is encoded in the IP header is the identity of source and destination machines. Once the network layer attaches its own header, the rest of the message is passed down in the TCP/IP stack to the next layer called data link layer. Data link layer attaches its own header. We call it as MAC header. And what is that information which is encoded in MAC header? The information which is encoded in the MAC header is the current node and the next node MAC address. We will discuss in detail when we will be learning L2 routing that how MAC addresses are encoded in the MAC header. And once the data link layer finished with attaching its own MAC header, the combined message is then passed to the next layer called physical layer. So you can see that the physical layer eventually places the data on the wire. So you can see that the physical layer eventually places the data on the wire in the form of electrical signals. Electrical signals are nothing but these are the varying high and low voltages where high voltage represent 1 and the low voltage represent 0. So we will not going into too much detail regarding the physical layer. So let us assume that once the data is placed on the wire by the physical layer, the data flows over the internet, passes through the series of routers and machines, and eventually reaches the receiving machine, which is the destination machine. So on the destination machine, what happens that once the data is received on the destination machine, the process of decapsulation happens. So let us say that the data has arrived on the destination machine. So on the destination machine, it is the data link layer which picks up the data from the wire. It examines the MAC header that was attached to the packet, and after examining the MAC header, the data link layer passes the rest of the message to the layer above it. So the layer above it, that is the network layer, receives the data and examines its own header, which is the IP header. We are assuming that the network layer protocol running is the IP protocol. So the network layer detaches its own IP header, examines the IP header, and passes the rest of the message to the layer above it in the TCP/IP stack. That is, it passes the rest of the message to the transport layer. And the transport layer does the same thing. It detaches its own transport header, it examines the transport header, and passes the rest of the message to the application running on the top of the transport layer. The application finally consumes the data, or optionally, the application can reply back to the sending machine. So as you can see that in data decapsulation, whenever any layer receives a packet from the layer below it, it first examines its own header, and depending on the header content, it may choose to forward the packet to the layer running above it, or it may discard the packet. So what is those criteria? What does the layer actually examines? That we will discuss in detail when we will be discussing each of the layer of the TCP/IP stack in the subsequent modules. Data encapsulation, each layer attaches its own header and passes the message with its header to the layer running below it in the TCP/IP stack. And in data decapsulation process, each layer receives the data or packet from the layer running below it in the TCP/IP stack. It detaches its own header and passes the rest of the message to the layer running above it in the TCP/IP stack. So this is the entire picture, that is a big picture of data encapsulation and data decapsulation. So next we will take a deeper dive into what actually happens during data encapsulation and data decapsulation.